happy to announce that we've got a workshop in June. Woo! And then I would like to. I'm working for startups. It's so close to stand-up, so. Okay, yeah. It's good? Yes. I'm so happy to announce that again, I'm happy to come to workshops in June. Thank you, Paweł. But you record yourself, of course? Yeah. Of course, everything works for you. Yeah. Come on.
All right, yeah, sorry. So for anyone watching, I forgot to press record for the first time around, but like we're good now, I think. I hope it's recording. So I'm Paweł. Oh, there's one, the clicker. It's somewhere here, yeah. Let's check if it works. So, no, not yet. And now? Yes, it works. Okay, so all of this is just to prove that we are not stuck up as corporations. We are not corporations. We are people, passionate people about what we do. We love the blockchain technologies. We love Web3 in general, and it doesn't really matter if something is not like working 100% during a presentation. It really doesn't matter. What matters is our passion for what we do. So I'm going to tell you about my passion because I'm a developer and apparently a workaholic, but like this is my passion, what I do. I'm doing oracles, and the question is, what are oracles? So I want to give you a short introduction into what oracles are and why they are the most important, one of the important parts of any blockchain ecosystem, because there is the blockchain, of course, and everything has to work there, but the blockchain is actually blind. The blockchain doesn't see anything beyond itself. It needs something and someone to put the data from real world into the blockchain. And what oracles do is do exactly that, but they are more complex systems than just putting data on chain, because anyone can do that, but is it reliable? So what oracles do, they put gossip, so unreliable data, anything that we like gossip. Yes, I know we like gossip, but like the gossip is useless until it gets turned into fact, because the fact, a reliable information, something that has really happened, is what we want to know on chain. And a short example would be, okay, let's say some people say weather. Like we can put weather on chain, but why? Like why would anyone want that? Like unless there's something happening with that information, then on chain, then weather could be useful. But apart from that, it's usually, like right now in DeFi, it's prices, like prices of assets, prices of whatever else anyone can think of, because then you use that as collateral and then mint something. But that's another talk. So oracles make this fact available on chain. And what is very important to me, and I'm super passionate about that, is that what oracles do is put the data on chain so it is available to smart contracts exactly during the transaction execution. Not before, not after, because that's crazy, but like it needs to be exactly on the same chain, because if it's not on the same chain, that you are adding additional risk of data availability. The data that you want the oracles for might not be available if it is not on the same chain that your project is on. So why are oracles? There is no DeFi without oracles. That's what I said. Like, we could create some systems that could operate inside the blockchain, but even now or many years ago, people realized that it is not enough to just work inside the blockchain. That's why we have different blockchains, but that's not the purpose of those L2s. The purpose of those is to make things cheaper, but we need data from outside world. So there is no DeFi without oracles. And how are oracles? How are they made? So basically, what oracles need to do is to query data from outside sources, be it exchanges or other projects or other chains as well, get that data, sign it with a cryptographic signature, which makes this data unchangeable, or if someone changes anything, then that would be quickly seen. And then it has to be stored. Stored on chain, as I said, on the same chain that your project is on. And what we had in Oracle's version 1 in 2017, when MakerDAO started, because Chronicle was part of MakerDAO for many years, and we were doing the same oracles, but right now we spun out, so we expand to more areas. But the Maker oracles, the version 1 of Maker oracles, which were actually first oracles on chain, worked like that. You had multiple validators, as we call them. They were collecting data, they were signing this data, and they were each separately storing this data on chain. That means that to get a Oracle update, you would need multiple transactions, which back then was very cheap, and that was not a problem. But when the transactions get more and more expensive, then you need to optimize. And then that's Oracle's V2. Oracle's V2, they removed the need of multiple transactions to do the update. We still have validators. They all sign the prices, and they send it to a peer-to-peer network. And then anyone that has access to this peer-to-peer network, which is open, so everyone can collect these signatures and then do a transaction. I'll get into more detail about the specifics, but that's basically how it works. So we save gas money, Ether, on having only one transaction. Of course, inside there, there need to be EC recovers, multiple EC recovers, but yeah, that works. But that, of course, became also very expensive with gas cost, with gas prices going very high. So we created Oracle's V3. Oracle's V3 is a ingenious way of optimizing for call data and for processing. So we call it Chronicle Scribe, and this Chronicle Scribe uses Schnorr signature aggregation, which comes from Bitcoin. It's not like we invented the Schnorr signatures, but we have them implemented in Ethereum using hacking a little bit on elliptic curve cryptography. And we optimized for call data size. So instead of having multiple signatures, and in our case it is 13 signatures that you need from 13 different independent validators that you need to get an update. Other oracles do 4, which is crazy low. So we optimize the call data because the aggregate signature is just one signature. And then we improved on the efficiency of gas efficiency of that even more because we added optimistic updates. So we optimized for compute cycles, meaning that where compute cycles are expensive, meaning Ethereum mainnet, we have a way to just verify one signature and be relatively safe on that chain, but to make sure that it is all working properly and that it is safe, we created a challenge bounty because the optimistic part is that you have 10 minutes of challenge period that allows you to challenge the optimistic update. If you win, if you manage to challenge it, meaning someone posted a bad price, you will get 1 ETH. So we ensure verification. Where are oracles? So this is simple. You can just go to chroniclelabs.org and see our dashboard. This QR code you can also scan and go there. It's funny actually about QR codes because it's a good phishing method. Exactly. And then the main thing I would like you to remember is that your protocol is only as strong as your weakest link. The colors are, you don't need to look at the colors. Anyway, oracles from Chronicle are the strongest ones because we use 13 signatures instead of 4, and we have independent validators instead of everything being inside one company. So knowing your oracles make you protected against being described on wrecked. And that happens quite often, not always the fault of oracles, but still, like, if it's like people say it's an oracle attack, even if it's not. So you need to be very, very aware of what you're doing. And what you need to look at when choosing an oracle is the oracle properties. So how accurate is this oracle? You need to know how many independent sources were queried, how this was modeled and calculated. For example, we use a median of medians, which means that the validators are doing a median out of different data sources, and then they send us the price, and then we do another median of 13, like a collection of 13 signatures, and we choose the middle value, and median is way better than average because median just discards the values that are not in the middle, and not like in an average calculation would, like, every price would have an impact, even if a slight one would have an impact on the actual price. But in median, we just choose the value in the middle. So if everyone's lying, they are either too low or too high. And with 13 signatures and 13 participants in this, you can be fairly sure that it's fine. So how is the integrity preserved? So cryptographic signatures, hello. Consensus, how is the truth determined? So is it a signature, a music of 1 of 4 or 4 of 7, or as with our situation, 13 of 25? Data availability. That's why I'm very passionate about talking on the topic of data availability and putting the oracles on the same chain that your project is on. Because if it's on another chain, the other chain can go down and then you're screwed. If it's in a database somewhere else, the list of signatures, if it's on a database somewhere else, the database can go down. But if you put it on the same chain, if the chain breaks, you have bigger problems than oracles. So, like, to mitigate most of the risk of data availability, you just put it on the same chain. What? I haven't heard of them. But let's go about, talk about it later, okay? So cost, of course, is something you need to look at. How much does it cost? And as I said, we optimized for cost quite a lot. So the optimistic update is just 1 EC recover, which is cheap. And we can scale infinitely because the optimistic signature has always one signature to be verified, and then the Schnorr signature also, even though it's not that cheap as just verifying 1 EC recover, it is cheaper because the call data is less. So there's smaller call data, still cheaper. Transparency, that's also a very important thing when choosing oracles. You need to look at who is actually verifying the data. In Chronicle, we use OG projects like Etherscan, like Gitcoin and such, and some exchanges. So these are projects that put up their reputation on chain as collateral, you would say, collateral to do the update. So if they would do something wrong, something bad, if they would mess with the price because they could sign something fake, we would immediately know. Not only we would know, everyone would know. And if Etherscan, for example, was responsible for some Oracle hack because they sent a bad price, that means that their reputation is down the drain and like doesn't exist. Permissions. This is also an important parameter because in Chronicle oracles, anyone that has access to the signatures can do the update. There's no permission on sending the transaction to the contract, provided that you have the signatures. And getting the signatures is also super easy because you can find it in a peer-to-peer network, which is open. You can just go to that network, listen to the traffic, and capture what you want and do the update. And you actually could do, like if you wanted, you could do an update before you do transactions, so you get a better price, maybe. But that really depends on projects that use that, because Maker, for example, usually has an intermediate contract that has a delay. So we know the price in advance, but the price will be finalized only at some point. So permissionless, great, the best feature. And always when evaluating oracles, you need to look at the probability and the impact of a situation. The probability, how probable is it for this problem to occur, and the impact, like what would happen if this problem occurred. And like there are many points and many areas that you need to look at when trying to evaluate oracles, but that's mainly the idea. Like you need to take each area and verify it against this. So that's what I would like to leave you with. Do not trust. Verify. Always verify. Verify your sources, verify your oracles, verify the validators, verify everything. Because trust, we cannot afford trust in crypto. So yeah, I am Paweł. I am in Chronicle and Chronicle Labs. I'm also in the ETHWarsaw conference and hackathon, and I'm also in our new startup called Tatena, which we are going to build, and which we are building to create Web3 solutions. And yeah, that would be it. Thank you very much. Would anyone like to say something? A fireside chat or some questions or whatever? I'll give you the mic.
You say the super important is verify, just so next time I verify your record. Okay, guys, now I would like to welcome you to the stage because we would like to have a group photo for this meetup. And after that, I would like to invite you to have burgers. So, może wrzuć Filecoinowe ten. O, super. Okej. Tylko żeby się wyświetliło.